Hello, mathematicians! It's Miss Scott again, and we are going to cover polygons in today's lesson. The first thing that we gotta discuss is what is a polygon? I've got a pretty good joke about polygons, so if you really want to know it, come find me. I will tell you. But the mathematical definition of a polygon is a many-sided figure with straight sides. So a polygon cannot have any curves. A circle is not a polygon. All right, so there are some special names for certain polygons. If a polygon has 3 sides, we call that a triangle. 4 sides is a quadrilateral. 5 sides is a pentagon, like the government building is a pentagon. Fun fact. 6 sides is a hexagon. 7 sides is kind of a weird one. It is a heptagon. 8 sides is like stop sign, which is an octagon. 9 sides is a nonagon. 10 sides like a decade. 10 sides is a decagon. There's no special name for an 11-sided, so I'm sorry. Let's take a moment of silence for an 11-sided polygon. It is nameless. Okay, that moment of silence is gone. So now a 12-sided figure is a dodecagon. And for any other shape, so an 11-sided figure, 13, 50-sided figure, you say whatever the number is, you put a hyphen, and you put gon. So an 11-sided figure would be an 11gon. Or a 13-sided figure would be a 13gon, and so on. So if it's not in this table, any other number, just number hyphen gon. Alright, so now we have some terms here for types of polygons. A convex polygon tells us that all of the corners, which we call vertices, go out. So let's draw a little picture here. Like a house is convex. It doesn't go in at all. A concave polygon has one or more, could have several, vertices go in. So for example, say we've got these 3 sides, and then, oh no, our house's roof caved in, so this point right here, where it caves in, makes it concave. Equilateral means that all sides are congruent. So, for example, a square is equilateral because all the sides are the same length. Equiangular says that all angles are congruent. So if you have a triangle and all of these are the same measure, that triangle would be equiangular. And a regular figure is 2 things. It is equilateral, so all the sides are the same length, and equiangular. So all of the angles are the same length, or same measure. So it's equilateral and equiangular. And we already mentioned a square, but a square is regular because all the sides are the same and all the angles are 90 degrees. So we call that a regular polygon. So let's do some classifying with some different shapes. In these 4 examples, we're going to classify by the number of sides, and then we're going to say if it's convex or concave, and then if it's equilateral, equiangular, regular, or it could be none of those. We'll see. Okay, so number 1, look at all those sides. There's 1, 2, 3, 4, 5 sides. 5 sides means it's a pentagon. All right. I don't see it anywhere where it caves in, so it is convex. All the vertices go out. And all the sides are the same length. All the angles are the same measure. So if it's both, we call it a regular polygon. All right, example 2, looks like we got 1, 2, 3, 4, 5, 6 sides, making it a hexagon. Also looks like all the sides, all the angles go outward, so it's convex. And it is equilateral and equiangular, so it is regular. All right, number 3. Classified by the number of sides. It's got 1, 2, 3, 4 sides, so that is a quadrilateral. And let's see, convex or concave. Looks like nothing caves in, so it's convex. And all the sides are not the same. All the angles are not the same, so it's neither equilateral or equiangular, so it can't be regular. So it's none of those. And last but not least, we have this plus sign looking shape. Let's see, number of sides. I'm going to start here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is a dodecagon. And it looks like it does cave in. So this is a concave figure. And all the sides look like they're the same. And I know it's tempting to say that all the angles are the same, but when you're talking about the angles, you have to talk about the angles inside. So I know this right here is 90, but this actually would be 270 degrees. So the angles inside the figure are not all the same. So this is only equilateral. And it turns out that a concave figure cannot be regular, so it can't be equiangular. All right, so there's a little practice of classifying. Let's move on to some drawing. So we're going to do some sketching here. We're going to, in number 5, sketch a convex nonagon. A, B, C, D, E, F, G, H, I. So we almost got the first third of the alphabet. Now when I draw this, I don't like to draw the lines first because I end up not leaving enough space and then it's a mess. So I'm just going to make 9 points. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Actually, I'm going to need to make this one go up a little more so that's not straight. And I'm just going to label those points from A to I. I always find myself singing the alphabet song when I label points. Okay, now we just connect those with straight lines, or as straight as possible. It doesn't have to be perfect because a sketch is just freehand. It's just kind of a rough representation. So if it's not perfect, don't beat yourself up about it. So this would be a convex nonagon, A, B, C, D, E, F, G, H, I. All right, number 6, a regular concave triangle ABC. Well, okay, let's try that. A, B. Now, where the heck am I going to put C so that it caves in? If I put it here, let's see. Now I know, like, you could think this, but now it's got 1, 2, 3, 4 sides. It's not a triangle anymore. So what if I put C over here? It's still not caving in. You know, I don't think this is possible. I think whoever wrote these notes is trying to trick me. This is actually impossible. Who wrote this question? I'm going to find them. Okay, so that's not possible. In fact, you can't make a concave triangle you can make a concave quadrilateral. We just saw that. That's like this. But there's no way to put 3 points and make one of them go inward. So, sorry triangle, you can't be concave. All triangles are convex. Fun fact. Alright, last example for today, some algebra. Woo! So in this figure, it is a regular nonagon. Do you remember what regular means? I do. It means that all the sides are the same. So all sides are equal. Whoa, where'd the E go? All sides are equal. Well, if that's true, this side and this side have to be equal. So we can use algebra and set those two expressions equal to each other. X squared plus 2x plus 40 is equal to x squared minus x plus 190. And I know you're looking at it and say, oh my gosh, there's an x squared. But check this out. We're going to start by subtracting x squared from both sides. And good news bears, they actually cancel. So this and this go away. And now we're just left with 2x plus 40 equals negative x plus 190. So this isn't too bad now. I don't like negative, so let's add this x over to the left. And these cancel. We end up with 3x plus 40 equals 190. Let's go ahead and subtract that 40 from both sides. So 3x ends up being equal to 150. And if we divide by 3, x is 50. All right, so I know that looked kind of scary, but good news is those x squareds canceled out, so we didn't have to worry about any factoring. You'll do plenty of that in Algebra 2, trust me. All right, well, I appreciate you guys tuning in today. If you have questions, feel free to comment or come find me, and I look forward to seeing you next time.